So the next question is capacity to ship packages within D days. I will explain you what the question is telling. The question is telling that I will be given with a integer of arrays which are representing different packages. Each one of them is representing the weight of a particular package, and I will be given a fixed number of days within which I have to ship all the packages. Now how can I ship this? I will load these packages in a ship and then I will depot it. This ship will have a capacity and I cannot exceed that capacity, and the other constant is that this weights over here, these packages can be sent in order only. It's not possible to send this product along with this product along with this product. The order should be maintained. Now if I tell that this boat has a very large capacity, suppose 10,000, the capacity is 10,000, then obviously if the capacity is very large, then what I can do is I can group these packages in any order so that I can divide it into 3 days and then I will be sending it in the boat in that order. I can divide it in any order, right? In any order I can send these products in 3 batches because I have to send it exactly 3 days. But the problem is we have to assign a very minimum capacity to this ship. If it is very large, then it is of no use. We have to find the minimum capacity that I should assign to this ship so that all the packages are delivered within 3 days and in order. Cool. So what I am implying now is, if I had just now I showed you that if I take a very large value, that is not beneficial. So let me pick a very small value. Suppose if I assign a capacity of 1 to this boat, then is it fine? The answer is no. Why? Because if this boat has a maximum capacity of 1, then how will I ever load these products out here? These products will never be weighted because their weights are more than the maximum capacity of the ship, and we cannot break the products and send them. So basically, in order to facilitate all these products to be placed in the ship's minimum capacity should be the maximum of the weights. Now talking about the brute force approach, if I know the minimum capacity, then I can directly calculate that if for the given capacity 4, what will be the number of days, within which I can ship all the products. Given this capacity, I have to find out in how many number of days I can ship all these things. So this is again very simple, this is simple programmatic approaches. So what I can do is, I will be having a variable, for example capacity, that I will assign it with the maximum value in this array, which is the minimum allowed capacity of the boat, which is 4. So at least it should be 4. Now if I try to find out how much days are required in order to ship all the packages, if the allowed capacity is 4, I can set the value of a variable capacity to 4. Then what I will do is, I will iterate through this array over here and I will maintain a days variable as well. So I will maintain a capacity variable and a days variable, and the days variable will be initialized with 1 because this is the first day, and now at starting the capacity that is allowed is 4. Now as soon as this first element over here comes, this element will decrement the capacity to 1, it will decrement by 3, so it will become 1. Now when I move to the next element, I will check if this capacity 2 can be accommodated. The capacity is 1, the number is greater, so I cannot accommodate this. So what I will do is, I will go to the next day, I will increment the days. This is a day variable, days is already in the question. So basically what will happen is, I will go to day 2, so my capacity will also be renewed to 4 because it is a fresh day. Now this 2 will be accommodated in the next day and my capacity will be decreased to 4. Now it will come to this 2 over here, this 2 will also decrement the capacity to 0. Now I move to the next package. This package will see that the capacity, there is no more remaining capacity. So basically I will take a different day and I will reset my capacity to 4. After that, for this 4 I need to decrement the capacity, so it becomes 0. So as soon as it becomes 0, when I come to the next one sees that the capacity that is left is 0, which is less than my weight, so I will increment the day. So on this day, this package 1 will come, the capacity will also be renewed, and this 1 will be taken account and it will be decremented to 3. Now the next package says I am a package with weight 4, but the allowed capacity for the day is 3. So I will take a new day, my capacity will reset, and now this last final product will be accommodated, and I will need a total of 5 days guys in order to ship this if the capacity allowed is 4. Now I don't want that. I want to be shipped within 3 days. So what I should do? I should increment the capacity. So when the max capacity is 4, I can ship all the products in 5 days. Sorry, I reversed the table. So you can get it. Now that is way more than our expectation. So we would increase our capacity now. I would now do it for capacity 5, right? For capacity 5, I will do the same capacity and days thing. You are getting the point, right? How to calculate the days given the capacity. So if the capacity is 5, let us do it quickly. What we will do is, on the first day, we will accommodate this. On day 1, we will accommodate this 3 and 2. On day 2, we will accommodate only the 2. On day 3, we can accommodate 4 and 1. And on day 4, we can accommodate 4. Okay. So with this also, when the max capacity is 5, then also I need how many days? I need 4 days. So I need to further increase the capacity. So now the capacity becomes 6. So when the capacity becomes 6, let me quickly do. For day 1, we will be taking 3 and 2. For day 2, we will be taking this 2 and 4. On day 3, we will be taking 1 and 4. So I can tell you that within 3 days, I can ship all the package when the max capacity is 6. So this is my answer. As we were iterating from the minimum value possible, the minimum value possible of the boat was 4. So we were incrementing from there only. So I am sure that 6 is the minimum weight that can be assigned to this boat in order to ship the given packages within the given number of days, within 3 days. So this is the approach, guys. Now now if we talk about the time complexity of this approach, it will obviously be order of how much. So basically the range, this range we have talked about in the starting, this range can be the maximum element in the array, max element to sum of array, sum minus max element, because I can, in worst case, I need to iterate from whatever the max element in this case was 14 and the sum was 16. In worst case, for example, in some cases the answer would have been 16 only or 15. So in that case I need to iterate for the whole amount from the max element to the sum of the array, to the whole length I need to iterate. So that much, and for all these iterations, for each one of these iterations, I need to again iterate through the whole array which is of size n in order to find out how many days that particular capacity will take. I hope it is clear. This is the order of, this is the time complexity, and obviously you can say that this is quadratic in nature because this is the product of two very significant values. Now what I want to do is, I want to reduce this time complexity to go to the optimal solution. So as soon as in the beginning of the videos, when I told that the range is this much, max element to sum of array, then only you must have thought of binary search. Binary search is the technique which will be used over here to optimize the solution. I get the fact that obviously as you cannot tell that this is a binary search solution as soon as you read the question, but as soon as you go a little deep, binary search should be seen, right? So as this range of max element to sum of the array, this range over here, this is linear in nature. So instead of checking for 4 and then linearly iterating to 5 and then to 6 and then to 7, I can, using binary search, I can take a mid value, that the mid is what? Mid is the capacity that we are assigning to the boat. Now if the ship has a capacity of this mid, then how many days is required to ship all the packages, that also we can find out, number of days. If I found out the number of days, we can compare this day with the days that is given to us in the question. If we found out that the number of day required with this mid capacity is greater, then we need to reduce it. I mean, we need to reduce the number of days, so we would need to increase the capacity. So in this case my start will move to mid plus 1. And in the other case, when the day that we have is less than the number of days, then what is the case? Then we should move our end to, guys, take special note, to mid only. Why? Because we are saying that whatever you are allowing us to do it in 3 days, I am doing it in 2 days. So okay, no problem. Maybe you are doing it in 2 days using a X capacity. Now maybe if you decrease the capacity, then also you can do it maybe in 3 days only or maybe in 2 days only. So let me check for that. But maybe this is the only minimum thing that is possible. Now, if this is the minimum thing possible, then also I need to check for all the other elements as well. But after checking those elements as well, maybe this turns out to be the result. So if this turns out to be the result, I cannot reduce the search space and remove it from our search space. As soon as my start moves from mid plus 1, the search space is reduced to mid plus 1 to end. But here the search space should lie from start to mid, because the mid, the last element, can also be the candidate result. It is also already an answer, but we will try to find out a lesser capacity. But if we do not find one, that should be written. So we bring our mid to over here only. And I would like to add over here only that because we are not making our end move to mid plus 1, that is why our while loop, in case of normal binary search, it runs from start is less than equals to end. If you cannot understand why, you can dry run on a single element 1 with a target of 1. You can understand why this equals to is required. Otherwise this will go to a infinite loop and it will not give you a solution. Cool? Or it will just give you a wrong answer. So in normal binary search scenarios, we use this equals to sign, but here if we use this equals to sign, this will go and run for a infinite loop. So that is not desired. So we will not use this equals to sign, because we are not decrementing my end to mid minus 1, we are decrementing it to mid only. As simple as that. These two things are, I hope, clear. Now what is next? The next important part is, if you see the question, it is said over here in the constants part that the wait's length is always greater than the number of days. So basically, if we come across a particular capacity, which is, if we take that capacity as the weight of our boat, then it will ship all the packages before the given amount of days. Then we can say that that capacity can also send all the packages within that many days. Because if, for example, we had two packages and we had to send them in 3 days. Okay, we have to send them in 3 days. Now what I can do is, I will not be able to do this problem. I cannot solve this problem because the minimum capacity should be 3. If the minimum capacity is 3, then I will be able to send these items in 2 days only. Sorry, the minimum capacity should be 2 and I should be able to send them in 2 days. I cannot take a lesser capacity or a more capacity. More capacity will again send it within 2 days only, and a lesser capacity will not be able to send these items. So, but this type of test cases are not over here, because over here the number of elements are always greater than the given number of days. So if we find a particular capacity which delivers all the packages before the time, then also we can able to use that particular capacity in order to send them in the given number of days. We will just divide it and we will send less amount of packages. We can do that. We don't have to worry about it. I think that's it, guys. I have covered everything in the theory. Let us quickly see the code. I have explained everything, like the binary search and how we, given a given capacity, how we will calculate the number of days required to ship all the products. So we'll start with the code. So first let me take the length of this weights array, weights dot length. After that I'll need to find the min and max capacity. So I'll declare those variables, min cap for example, which is, I'll declare it as 0 because all the weights are greater than 0, so I can assign it as 0. Then max cap, I'll again assign this to 0. Okay. Now what I need to do is, I'll iterate through the array, int I equals to 0, I less than n, I plus plus. Then within this loop I will try to find the max, and that should be stored in min cap, because the max in the array is our min cap. Math.max of whatever the value in min cap is, that along with the current element, right? After that, for max cap I need to calculate the sum of all the elements. So plus equals to the current element, weights of I. So here also it should be weights of I, guys, right? After that I need to run my while loop, like the binary search. So this over here, this while loop I have already explained why the condition over here should be less than, right? After that, what we need to do is, we will find mid, and mid equals to start plus, min cap plus max cap minus min cap by 2. Obviously guys, I hope many of you will know it, but we can also do min cap plus max cap by 2, but there the problem is that if min cap and max cap are both very big integers, so basically adding them up will exceed the range of integers and we can get an inaccurate value, right. So this is the best way. Over here we are subtracting, so no way a big value will be stored, right. So yeah, we are calculating the mid. After that, what we need to do, I will consider that the mid is our current capacity of the ship, and for this capacity how many days are required to ship all the packages, we need to find that. So I will run a for loop to iterate through the entire weights array, and what I will do is I will first check, okay, I will declare two variables. First there will be a capacity variable, int capacity should be there, which is equals to mid, and also I would take days, sorry day, the name of let me take it as d is 1, I will assign it with 1. So on day 1 the capacity is this mid variable. Now what I will do is I will first check while the current element weight, so sorry, not while, it will be a if, right, I will just check, this is a conditional statement, while weight of I, sorry, weights of I, if it is greater than capacity, then what I should do is I should increment my day d, and I should assign capacity to the value of mid, because in this particular iteration, in this whole iteration we are trying to find out if the given capacity is mid, then how many days we require to ship all the packages. So I will again reassign the value of capacity to mid, and after that in every iteration, even this condition matches or does not matches, what we will do is from capacity we should decrement the current weights of I, okay. In this manner, after the whole iteration, my d variable will hold how many days are required in order to ship all the packages if the given capacity is this mid. Now after that I need to either change my start or the end in this while loop. So what I will check is if the number of days that are required that we found out, if it is greater than the required number of days, then we should increase our capacity. So my min cap should move to mid plus 1, right. Else I have told you already, my max cap will come down but not to mid minus 1, it will be coming back to mid, and that is why only we have eliminated the equality sign over here in the condition. Now as soon as this while loop ends guys, I can return my min cap. Now why I can return my min cap, I will be coming, but let me just run this code. Okay, it is accepted, let me submit it. So it beats 92%, right. So now I will just talk about, I'll let you know why this min cap is getting returned, give me some time, but before that I would also visualize one particular observation, okay, one enhancement. Suppose consider that the weights array that is given to us is suppose 443, suppose this is given to us, and the number of days that is given to us is 2 days, okay. Suppose within 2 days I need to ship this package. Now tell me what should be the minimum amount of weight that can be assigned to our boat. It is obviously the max of this element, which is 4. Now think logically, if in one day I am allowed to send 4, this is the maximum capacity, right, then in 2 days I can ship a maximum of 8 units of weight, but I have 11 units of weight over here, okay. So the range of the answer according to our current method is 4 to 11, but what I am saying is if I take 4, then I will be able to ship only 8 units of weight, but I need to send at least 5.5 units of weight daily. What I am saying is that my minimum cap will be the maximum of whatever the maximum is in this array, which is 4, or whatever the maximum of the total weight divided by the days. Among these two, whatever will be maximum, that will be our lower bound. So if we are trying to maximize the lower bound, basically we are reducing the search space. So that will be a little bit of enhancement. Let me quickly run you and show. What I am saying is this min cap, after I found the sum and the min cap, I am saying that min cap will be math.max of the current min cap or max cap by days, total by days. So basically I am maximizing my min cap and my search space is decreased. So let me see if it is enhanced, but you can understand, right, that this is basically, so it is enhanced, it is beating 97%, right? Cool. So okay, I have to also explain this min cap thing. So cool guys, it will be a little longer. You search any other video, they will not explain you these things, that why min cap is getting written, they will just show you the code. So obviously guys, I would also like to add that if you are reaching this question of binary search, maybe somewhere down the line you have solved this question, seal of a number, okay, then in Leetcode there is a equivalent to this. This is in GFG, there is a equivalent question in Leetcode which says search insert position, I think search insert position if I am not wrong. So that question also, over there you need to always return the left or low, whatever you call it, right, and that should always be returned. Similar logic is used over here. Why min cap is over here? So you over here, why it should be, because every time when at the end of the iteration, whatever the result is, my min cap will be pointing to that only. That is why we are returning it. So why that is happening, I will try to give you a little bit of idea. Suppose whatever the array is, suppose it is 1 2 3 4 5, okay, suppose this is the packages, weight that is given to us, and my start is over here and my end is over here, okay. Now what I am saying is that I will find a mid, this will be my mid, and after that if the capacity is 4, there will be a certain number of days where we can ship all the items. If that day, suppose let us assume that 4 will be the answer. So in this 4 days we will be accommodating it in same number of days or in lesser amount of days. Suppose we do it in lesser amount of days, so or in equal. So in both the cases my end will come to mid, not mid minus 1. So after that maybe I will find out a different mid, I will try to work out this, then ultimately it will not work. So I am not stopping over here, right? As soon as my 4 became smaller than the expected number of days, we did not stop over there, we will be searching this space. Ultimately either again my end will move to somewhere here or my start will move ahead. So in all the iterations guys, you will find out that at certain point my start will be pointing to a element and immediately the next element end will be pointing to. This particular situation will arise in all the cases, because we are either moving the end to the mid, or and after that we are either moving the start to whatever the new mid is plus 1, or we are again moving the mid to equals moving the end to mid. So this situation where my start and end will point to 2 consecutive items, this situation will arise in all the cases, okay. Then in those cases what will happen is, suppose if over here whatever the element is there, that is the answer, over here x is there, over here y is there. Suppose y is already giving me a lesser number of days than the required amount, and suppose x can be the potential. So if x becomes the answer, start is now at x, so my mid will also be at x, right? If my start and end is pointing to 2 consecutive element, always the mid will be the smaller value, because we are ignoring the decimal part. So my mid will always be in the start, and I will be computing for this element. Suppose there are 2 possibilities now, this can give me the answer, this can be the answer, or if this is taking more number of days, then y will be the answer. So these are the 2 cases now. So in both the cases, if this becomes the answer, then what will happen is my end will come over here. Once my end comes over here guys, then the iteration will stop, because my condition is while start is less than end. So as soon as start and end becomes equal, my iteration will stop and my start is pointing to the answer. And in the reverse case, if x is not the answer and y becomes the answer, what will happen is the number of days that we find out for this particular capacity will be greater than what is required. So we will be moving my start to mid plus 1. My mid was over here, I will move my start to mid plus 1, which will be pointing to same as end. Now again my start and end, they both will become same. And thus we will end our iteration and you see that the start was pointing over here only. So in all the cases at the end of the iteration my start which is min cap in our code will always point to the answer. Cool guys, I hope things are clear.